Hello, everyone, and welcome back to another spotlight for the coolest thing made in Kentucky tournament that we have going on in conjunction with CAM, which is the Kentucky Association of Manufacturers, and presented by Kentucky Farm Bureau. My name is Tom Lawson. I am your host of Built in the Bluegrass. We have another familiar face, familiar company, and maybe familiar product to you all. But we have Thieves here with us, and we have the marketing and communications manager that the last time we did something with them was their main point of contact and got all the stuff together for us. I guess it's been a little bit over 2 years ago now, but we are here with Justin Falck. How are you?
Hey, Tom. Good morning. I'm doing well. How about yourself?
Doing good. Just trying to really, at this point in time, survive all the storms and the rain that are coming through. It's
It's
driving me a bit crazy. I would like to go golf at some
I'm
point.
in the same boat, man. I just went to the driving range last night. It was raining, but at least under shelter, so it was nice.
Yeah, we have, we finally, located in Louisville. Sure, this might be the same for you all, but golf has a resurgence here in Kentucky, especially in Louisville. There's a lot of really nice golf courses here, but there wasn't a whole lot of nice indoor golf or really driving ranges. But it's changing over the last year and a half. We have a lot of, other than Top Golf, I guess that kind of started it all, but it's getting pretty good with the simulator
Definitely,
action around here.
definitely having its moment for sure.
For sure. All right, let's get into it a little bit here. I know we talked to you all once a couple of years ago, but things may have changed. I know you guys have a cool product that we're going to talk about that was nominated for the coolest thing made in Kentucky. But give us a little rundown about what Thieves has been up to since the last time we talked.
Yeah, for sure. Maybe I'll give you just an update on well, maybe a little background, a little history first. Feed Group is headquartered in Paris, France. The history there is they've been around for 200 plus years. We're involved with historic architecture in Paris, for instance, the elevator system for the Eiffel Tower. So there's a lot of history with the parent company here in Hebron. We stem from Cincinnati Millicron, or it was originally founded in 1884 as Cincinnati Screw and Tap. Then it was Cincinnati Machining Company. Then it was Cincinnati. Then it was Cincinnati Milling Machine. Then it was, Cincinnati Millicron through the 70s, and many people in the northern Kentucky and Cincinnati region are familiar with Millicron in some capacity. But about 2003, we moved over the river to Hebron, which is where we still are today. But the facility here, we're primarily in the metal cutting and composites industries, and meaning we manufacture equipment that we sell to our customers who then use that equipment to manufacture their parts. A lot of aerospace industry, especially on the composite side, which is what the product that we're going to talk about a little bit more today is in the aerospace industry. But then here also in this building, we've got our service division, which is helping our customers with parts and aftermarket retrofits, rebuilds, services of the like. Yeah, so Feeve is a huge company, lots of different sectors and industries. But out of this building, those are the primary ones that we're kind of focused in.
The hands in a couple of different honey holes, I'll say.
Yes, absolutely.
Yeah, aerospace. People don't think about aerospace and Kentucky, but it's huge. It's our second leading export.
Absolutely. Yeah, yeah. It's a big part of our business, not just in this building, but really around Feeve and especially the metal cutting and composites, or what we call our material removal and composites and automated solutions business units. names like Cincinnati, but also Giddings and Lewis and Linné machines. They're up in Granby, Canada, and Forest Linné out of France, and just a lot of global components being made. Honestly, there's not a commercial aircraft that people are flying on that didn't have some component or part that was touched by a Feeve machine.
Yeah, I think the last time we talked, one of the big things that the guy we talked to, he was saying a lot of it that you all did at the time was seats for the airplane and
Yeah, yeah,
machining the entirety of basically what the cushions obviously sat on, because they had to be a specific, incredibly specific, like zero margin. You know, everything on a plane is incredibly engineered, obviously. So everything has to fit perfect. There can't be there's no wiggle room for uh, thresholds or whatever you all would call them. Margins for error is literally zero.
yeah, for sure. That'd be one component that we would machine with some of our metal cutting or material removal equipment. Lots of aircraft still have plenty of metal and titanium, aluminum, these kinds of things on them. Not just commercial aircraft, but you're talking about you know fighter jets and helicopters and basically anything in the air. We can probably machine parts for it, but then also lay up composite parts. So really, we're talking about material removal on the machining side. On the composite side, it's sort of an additive manufacturing where and I guess that kind of segues us into the product that we were going to talk about today, which is the Cincinnati Robotic Viper. That product is a composite. It's an automated fiber placement machine, which basically means you've got small fibers, and our machine can do several different size fibers, but basically you lay up a bunch of layers of fiber so you get a thickness, and then you basically stick it in an autoclave and get it really hot, and then it sets in that form, and then you have parts like wing skins, air ducts, or fuselages. So a lot of the equipment that we make are composites machines on that additive side that customers are using to build parts like that. And you do that because with that composite material, those composite parts, you're able to get basically the same rigidity, the same strength that you might have from a metal part, but a lot lighter. Obviously, you're flying something in the air. You need to think about and consider that weight. So, but also you don't want to lose, the rigidity and the structure there. So, yeah, the Cincinnati Robotic Viper is actually a sort of a next gen version of the old Cincinnati Viper, which was also an automated fiber replacement machine, but it adds an element of a robotic arm, which we've got between the Cincinnati Viper and the Cincinnati Charger. We have the largest install base of composites equipment in the industry. So there's tons of customers out there that are using these component or these products to manufacture their composite pieces. But the the cool thing about the robotic Viper is it allows for a much lower price point of entry, and then also a much smaller footprint, a lot more versatility in the size and the types of parts that you're able to manufacture. That's one of the main selling points of a robotic system, and why we wanted to take what we had and what was great, and if it ain't broke, don't fix it, kind of a thing, but make it better. How can we take it to the next level and make it more accessible?
For sure. So I just looked up the picture, and I know people who are watching the
Yeah.
podcast won't be able to see that, and it's not on the screen, but I suggest you go look at it because it looks really cool. But to me, it almost looks like like a giant 3D printer on a track.
Yeah,
It's
I mean, honestly, the Fiber placement in composites, like I said, it is an additive manufacturing where you are laying material down and building something out. So it is very similar to what a 3D printer in that capacity, anyways.
Yeah, I'm sure that's a very layman's low level. This is what it looks like. I mean, there's a crazy amount of parts and things on what I'm looking at here, and I'm sure there's that just to the untrained eye, that's just what it kind of looked like to me. There's like big spools of material everywhere, and the looks like there's, a dispenser of material portion, a tip, I guess you probably would call it, but
So the what you might be looking at our website or just what we submitted for the tournament here. But if anybody is interested in looking and learn some more, you can just go to fivegroup.com, FIVES group.com, and then if you search the Robotic Viper, it'll take you right to the page where we've got tons of information about this specific machine, and there's a pretty good video out there that gives a good representation of what this thing is capable of. This machine in particular is a 16 lane Viper. So I mean, if you're probably looking at the picture, it's the robot is kind of an arm, and basically our technology really comes in the head of that robotic system, if you will, and 16 lanes, so that you got basically double that in terms of the number of spools that are on that head. So it looks pretty wild, actually, especially if you see it out there making parts. Basically, I have one spool of material that has the actual new material on it, and then there's 16 toes, we call them, that are laying the material. And as that material is getting pulled off of the new material spool, the backing of that is spooling up on another spool. So that way you don't have excess, extra materials, because these composite materials are very sticky. So you have to have that backing on them. Otherwise, they're going to stick to yourself, and you're going to have a ton of issues getting it onto the where it's supposed to be, onto the part.
nice. I had a client that they were in I would call it the smaller aircraft or almost boutique helicopters and things like that. But I was reading on your website there that this is a replacement for materials that used to be laid down by hand. And that was my only experience. So I went there to their location and saw they had, I wouldn't call it a spool, but giant rollers basically of this probably really expensive material that they were just building something that was like stamped out, and then they're pressing it in, doing another layer. So this is definitely a big, I feel looking at this, that is like a Stone Age almost technology. There's
Well,
probably a use case for it at some point, but this is like, all right, now we stepped into a new generation of materials and composites.
yeah, I mean, you might be surprised. There's plenty of companies out there that are still doing some element of hand layup of that composite material. But when you have like an influx of a specific type of part, and you're like, we got to make hundreds of these, and
Mhm.
hopefully in the next 5 years or so, with the Boeings and the Spirits of the world, and potentially the new single aisle aircraft, that we could see an uptick in the need for this type of equipment. But that hand layup stuff with composites probably started in the 70s, maybe earlier, and then come around to the 80s. And really, Cincinnati was at the forefront back then, working on the automated processes of how you can use equipment to get rid of that hand layup, so you can get more efficient. Obviously, you can control and have better in terms of your defects, and not having areas of low tolerance or issues with the parts that you're making. So that kind of took off, obviously, in the 80s, 90s, and we've been using composites in aircraft pretty much ever since. So there's a lot of potential here for this product in particular. So this one's a fiber placement machine. We say fiber. They got I think it's 1/8 inch, 1/4 inch, and 1/2 inch fibers. And then we also we have a what we call our Cincinnati Charger or Cincinnati Supercharger, which is the next generation version of the Charger. The Charger is basically an automated tape layer. So instead of a fiber, you've got 3, 6, 12-inch pieces of tape. So you're able to put down a lot more material all at once. The difference between the two machines really is a fiber placement machine. Because of that width of those fibers, you're able to make much more contoured parts, much more curvature and these kinds of things. Whereas a tape layer with the thicker parts or the thicker pieces of tape, you're able to make a larger piece, usually on a flatter piece or part, I should say, with that tape. So that was really the onset of why these types of pieces of equipment were utilized. Because at the beginning it was all done by hand, and then how do we make this more efficient and cost effective?
Yeah, for sure. You say cost effective, and I was just thinking, I'm sure by hand you have to pull out more material than you think you'll need, cut that off, and then that's just wasted. You can't use that anymore. So cost effective, better tolerances, all that equals, less waste is, I'm sure, the biggest thing in the materials business, and
Yeah,
more
absolutely. I mean,
accuracy.
yeah, for sure, accuracy, and that's what I was. Sorry, I cut you off a little bit there, but one of the coolest technologies that we're developing right now is actually our Coast system. It's an in-process inspection system. You would basically it's kind of a laser system at the end of the head of a automated fire placement machine or something like that, where you're able to in process, so real time, see how the toes are laying the material, and you can find defects in real time. So you said cost effective and accuracy. So if something is off on the part, rather than getting through the whole part and finishing things up, which is what they were doing before these in-process inspection technologies, you might get to a part and then there's a defect. So you might have to scrap a part, and you're talking hours and hours and hours of a machine doing the layup, and then the material itself. So yeah, you're losing a lot of time and money there. The in-process inspection system would obviously negate that and even further enhance the cost effectiveness and the accuracies and machine downtimes and all of these different things that we're able to do when we have that data coming in.
Yeah, that would be really bad. You're complete 99.9%, and then something messes up on that 0.1 and you have to trash it.
Yeah,
That is not good. Well, obviously that probably happens occasionally.
sure.
Yeah. So I'm sure this is proprietary to you all and you all use it, I'm sure. But is this something that you also develop and sell to other manufacturers?
The in-process inspection system,
The or the Robotic Viper.
yeah. So there are a few of these out there in production right now. So we've got a few customers that are actively using this product to lay up their parts. There are other various types of AFP using robotics, but none of them are doing basically the same stuff that we are. So everyone's kind of got their own niche.
Gotcha. Well, all right, Justin, it's been a pleasure. I won't take up any more of your time here, but any last, I would say last words, that's what popped in my head. Just any other tidbits or information you want to get out there about Thieves and what you all are up to?
No, I think just thanks for having me on today. Like I said, feedgroup.com or fivesgroup.com is how it's spelled.
Yeah.
And check out the Composites and Automated Solutions system. We just got back from a trade show in Paris, specifically for our composite stuff. We've got another show later this year called CAMEX. It's the biggest one in the U.S., really pushing these our solutions and what we can offer the industry. But yeah, no, I'm just follow us on LinkedIn. I'm sure you'll share on there, and people can find the latest and greatest stuff out there.
All right. I appreciate your time, Justin. Again, this is Tom Lawson. I am the host of Built in the Bluegrass. This has been a Coolest Thing Made in Kentucky spotlight with Thieves in conjunction with and presented by Kentucky Farm Bureau. We have been a sponsor of Coolest Thing Made in Kentucky the last 2 years. We look forward to having you all back on next year with either, maybe people see this product and they actually go look at it and they're like, oh, that was actually cooler than the thing I voted for this year. You never know. But again, I appreciate your time and we'll chat again soon.
Thanks, Tom.
Thanks so much for tuning in to this episode of Built in the Bluegrass. We hope you're leaving this episode with a better understanding of the cool stuff made in Kentucky. If you haven't done so already, make sure you're subscribed to the show. This way you'll get notified as new episodes become available. Until next time.